Okay guys, so we'll talk about recursion now, and recursion is a relatively tricky topic. Students find it difficult to grasp it, so take your time in watching the video. If you want to watch it again, go ahead, do it, but make sure that you go through the iBooks also, and there are tons of videos online on YouTube and other sources that you can find about recursion. So let's start with a question. So let's say that you have to find the nth power of a number, right? How would you write a code to solve it? Right? So this is an easy, right? So let's say you have to find an easy problem, right? You have to find 2 to the n or 3 to the n. You have to find the nth power of this number. What is the first thing that comes to your mind? And most of you would answer that you would write a for loop, right? Use iteration, right? But turns out there's another way that you can solve this, and that's through recursion. And that's what is the topic for today. And let's go through the iteration part, all right? How would you find the nth power of a number using iteration, right? So the idea is that you have to find the nth power of a number r, and so the mathematical steps in solving is that you would multiply the number n number of times, right? You multiply. So let's say you have to find the third 2 to the power 3, right? So you multiply 2 3 times, right? So the idea is simple, that you would write a for loop that runs n times and multiply that number again and again by updating a value. So here's the simple code that you can use to implement this. You have a value, let's say, this is the sum that we update, right? That you guys have been working a sum or product. So this is, you can call it product also if you want. So this is the base, this is the power, right? And these two, so we're calculating 2 to the 3 over here. You can enter any numbers over here. So then you would do for I in range, and this is gonna run the loop 3 times. So for 0 1 2, right? But this is just a dummy variable. We're not using this variable. We're just making sure that the loop runs 3 times. And so for every value for every iteration, we update the value of the variable value, and then print out the value outside the loop. So in the first iteration value, so in the first iteration, what happens is that base is 2, value is 1. So value becomes the value of the variable becomes 2, right? In the second iteration, value is 2. So base still stays the same. We're not changing the base, right? Now in the second iteration, value would be 2, so you get 2 multiplied by 2. In the third iteration, you have 4 multiplied by 2, so you get the final value, which is 8. So that's a simple algorithm that you can use to implement the problem of finding the nth power of a number. And this is just something in addition. You can convert this into a function where you enter anything that is base, anything that is power, and the program is just the same within that function, and you can call this function with any 2 values to find the nth power of a number. So whatever you enter over here is always going to be the base. This is going to be the power. So this is this number is 4 to the 7. Okay, so now let's look at recursion. How would you solve this with recursion? But let's first define what is recursion. The main idea behind the overall idea is that recursion is called recursion because of the recursive call of a function. So an essential part of recursion is that you would call the function within itself, which sounds weird. And you saw the picture in the on the first slide. It's just it's just a function that depends on itself. So that's why these, the series, like we've done the Fibonacci series, right? It is a series that depends on its, on the two preceding terms, right? So you can look at it this way. This function depends on itself, on the previous 2 terms, right? So in that sense, recursion is, is a similar concept, that the function basically needs previous values of the function to find the next one, right? So that's this successive, these successive calls have to be there in order to implement recursion. And there's a base case, and we'll see that what is that when we get into it. So let's look at the nth power, right, by recursion now. So the idea is that there is a base case that will make you stop, right? And then now, instead of multiplying that number n times, we are multiplying the base with the same base with a power less than 1. So you're essentially like calling the function. This is like, calling the function with a power less than 1. And so you keep on doing that until you get the answer. So let's see how would you implement this in Python. So now we have that same function over here. Now we have a base case, right? So the base case is basically this, right? This is what we're calling the base case, that you need to stop the program. If you don't have the base case, the program will just run forever, right? So when you have to tell Python that when it reaches this base case, it has to stop, right? And so when you return, when you get to this base case, you have to return the base only. Now, else, if you haven't reached the base case, you have to do this. You multiply the base with exponent and then base and then 1 power less, right? So this is that step what you're doing. You're multiplying the base and the base with a power less than 1. So this is the base, right? And this whole thing is r to the n minus 1, right? So so that's the idea. And let's see how the call stack works over here, right? So the call stack works in the following. You start, right, with, let's say you want to calculate again 2 to the 3, right? Now when Python starts running this, there are no values initially, right? Until Python reaches the base case, the stack is basically not a number, right? It keeps on calling the function, and when it reaches the base case, you start getting numbers then. So the exponent of 2 to the 3, when you call the function with this, Python goes in, right? And then this is again r. So this is again r, the base, multiplied by r to the 3 minus 1. So then which is 2, right? So this is 2 now, and then again it goes back and then multiplies that with so this is r to the 3 minus 2, right? And this is again you get this is r and this is r, right? So this is r squared. So now when it gets to this point, now Python can plug in the values, right? Now it reaches the base case, right? So when it gets to this base case, it replaces this with 2, right? So now it goes into the function and it finds out that the base case has been reached, and so therefore it returns the base. Now the base is 2 for our particular example, so it's going to return a value 2 for this part, right? And so therefore you get a 2 over here, and then it goes back and completes the calculation and then returns a value 8. Okay. So again, this is, so I'll repeat it. So when you call this function with 2 to the 3, you always get r multiplied by r to the 3 and then minus 1, right? 1 power reduced, right? And then you get r multiplied by, so now this whole thing, right, is going to be replaced by this whole part, right? So this is going to be r, and then r to the, well, 2 minus 1, 3 minus 2, same thing. So 2 minus 1, right? So then this is where you reach the base case, right? Now when Python calls the function again for this part, it reaches the base condition, and this is replaced by 2, and then it goes back, and then the stack is now filled up and it gives you a number. Okay. So So there's the whole picture that you have. The pseudocode for the recursive function is that you need an if condition, a base, right? A base case is important because the function is not going to stop if there's no base case. And then for the else part, this is going to be the recursive part where it keeps on calling the function itself until it reaches the base case. Okay. Let's look at another example, and I'm giving you the solution to one of the questions on the worksheet now. This is factorial using recursion. I want to, so let's go through this because it's a bit tricky. So now let's say you have to find the factorial of a number, right? And so the definition of the factorial, let's say when I find 3 factorial, then 3 factorial is all the numbers less than 1 less than 3, right? And then multiply. So you multiply all the integers less than 3 with that number. So 5 factorial is going to be like 5 times 4 factorial. Let's do it this way. And then 5 times 4 factorial is 4 times 3 factorial, and then you have 5 times 4 times 3 times 2 times 1, right? And so on. So that's the idea of the factorial. And so you can see it's a recursive. It has a recursive behavior because when you do 5 factorial, then 5 factorial would need 4 factorial, and then 4 factorial needs 3 factorial. So when there is this attitude in your problem, you can use recursion. So let's implement this. You define the factorial, right? And then you need the base case, right? So the base case, I would say, I would add or n is equal to 0 over here also, right? Because 0 factorial is also 1. So when n is equal to 1 or n is equal to 0, you return 1. 0 factorial is also equal to 1. Okay, so that's your base case. And so when you submit the worksheet, make sure you have that condition also, or n is equal to 0. Now in the else part, you need, so now you're calculating that, right? 5 factorial is 4 times 3 factorial. So you're calling the factorial function again with a number less than 1. So now let's say you want to calculate 4 factorial, right? That's going to be 4 multiplied by 3 factorial. So you have reduced the number by 1, right? And so 3 factorial is going to be 3 times 2 factorial. And so until the function reaches the base condition, it keeps on doing this recursion. So here's how the call stack works, which I've already discussed. So 4 factorial is going to be 4 times 3 factorial. 3 factorial is going to be 3 times 2 factorial. 2 factorial is going to be 2 times 1 factorial, right? And so that is where we reach the base condition. And so now it goes on and starts filling up the stack by filling up, by replacing these numbers. So 1 factorial is 1, so it becomes 2 multiplied by 1. 2 factorial is now 2, right? So it replaces 2 factorial by 2. And so you can see that you get 3 times 2 is 6. And then, so you get 6 over here, and then that is replaced over here. And so you get 4 times 6, and that's 24. And that's your answer. So that's how you look at recursion. You start basically, you don't calculate any number, right? You start calling the function with a power less than 1, right, typically, and then you go in the backward direction. When you reach the base case, you start filling up the stack with the numbers that you get to get the final answer. Okay, so that was it for recursion. Go ahead and solve the worksheet. This question I've already solved. Just make these modifications that I said in the function. One more thing is that you might want to add a condition that if the number is less than 0, the factorial for negative numbers does not exist. So you can add an elif condition if you want for that. But that's fine if you don't want to do that. Okay. So